Right, now to find the differentiation from first principles when working with hyperbolic equations is probably the most challenging type of questions that you're going to get. And here's how you do it. In this question, they gave me 4 over x, and I must find the differentiation from first principles, which means I'm going to use this formula. And then, as in the previous examples, I'm going to on the side find f in the place x plus h, but that is simply just now 4 over x plus h. And then I'm going to subtract, which I can't really do anything with. And then I'm going to subtract the fx from this. And this will then give me 4 over x plus h minus the function 4 over x, and this is where the tricky part lies. Right, so you have two fractions, and just to remind you of what happens with fractions, in normal fractions, when you have a half plus a third, when you add or subtract fractions from primary school, what you used to do is you go put them on the same common denominator. So between 2 and 3, I can multiply 2 and 3 with one another and then make it 6. So I can put them both on 6. And then whatever you do at the bottom, you do at the top. So in the numerator, denominator. So in the denominator, I multiplied from 2 to get to a 6. I multiplied with 3. So then I'm going to take this 1 and I'm also going to multiply this with 3. Yes. And then the 3 I'm going to multiply with a 2. So the 1 on top I'm also going to multiply with the same thing, a 2. And 1 times 2 is 2. And then you can add that 5 over 6. Now this is going to work exactly the same. That's why I show you this. If you just remember this, it works the same, except for now there's x's and h's and all sorts of things. Right, so I'm going to put this on the same common denominator, which is this times this, which will be x times x plus h. Right, and if you looked what happened from this denominator now to that one, this part, this x plus h, got multiplied with an x. So I'm going to multiply that numerator, the 4, I'm going to multiply that also with an x. So I have 4x, right? And then there's a minus. I'm just going to write that. And then from this denominator to that one, there's a x, which is there. And then I multiplied with a x plus h. So at the top, the 4, I'm also going to multiply with an x plus h, like that. Okay. So this step is really important. If you forget how to add or subtract fractions and you don't start out like this, then the whole thing from here is a complete mess. So please just make sure you understand what's happening here. And then from there, I can simplify the denominator, the numerator, to be 4x minus 4h over, and this you can actually just for now just keep like that. It's not necessary to multiply this in, but this one I must, and 4x minus 4x is 0, so this becomes minus 4h over x plus h. Right, and this is now the numerator of that fraction, so I'm going to use this like such. I have minus 4h over x plus h, and now technically this is over h, right? But this is just very unneat and complicated, so instead of writing the over h, I'm just going to write divide by h. Okay, divide by fractions. If you remember from fractions, divide by h, which is h over 1, yes. To divide with a fraction, we can't actually divide by fractions. What we simply do is we multiply with the reciprocal, and then those h's can cancel out. Right, now this over h or divided by h is where my problem lies. So multiply with h over 1. This is where my problem lies in making the h 0 because I can't divide by 0. And the moment this cancels out, I still have a h, but it's not a problem anymore. All right, so now I can just make because the h is not my denominator as a whole, there's other things too. So that being a 0 is not really a problem. So I can just from there substitute that h to be 0. So I have minus 4 over x plus 0, which is simply just x, to be honest. And you see I'm not writing the limit anymore because I substituted the h to be 0 now. So I don't need the limit anymore. And then this is just x squared. Right, x plus 0 is just x, and x times x is x squared. And that is my derivative from first principles. Right, I'm going to do another example like this. It might be a good idea for you to just pause the video, write down the question, pause the video, see if you can do this on your own, and then come back and check the answer. Right. Okay, so have you paused and did your own thing there now? I'm going to start out by just substituting f in the place x plus h. So if I make minus 3 over, if I make the x plus h now, it looks like this. And then I'm going to take this and I'm going to subtract the fx. Okay, so this will now over, I'm just going to put that minus up there actually. I'm going to subtract the minus 3 over x, my function. Right, now this minus negative is going to become a positive. I think I'll just write that in one step so that I don't confuse my signs. Okay, and then I'm going to make this all on the common denominator x plus h. You'll see all of them works roughly the same, but you must just know how to do this, right? So from there to there, at the bottom I multiplied with an x, so the minus 3 on top I'm going to multiply with an x, and from there to there I multiplied with x plus h, so my plus 3 at the top I'm going to multiply with x plus h. Right, so I have minus 3x plus 3x plus 3h all over x plus h, and minus 3x plus 3x is going to fall away, and this is now my numerator in this formula, which I have not written yet. Let me just quickly write the formula there. X plus h minus f in the place x over h. Okay, so this is now my numerator, which is 3h over positive 3h over x plus h, and yet again I'm just going to write divided by h instead of doing over h. I'm just going to write divided by h, which then obviously becomes times 1 over h, and then the h's can cancel, and now I don't have a problem anymore, so I can substitute the 0 in. Then this becomes 3 over x plus 0, which is just x again, and then this is 3 over x squared. Right, so this is the hyperbolic differentiation from first principles. I think this is the trickiest one, but it's not impossible.